Now, this is the question number 2 from paper 42, 2024, May, June, IGCSE, course number 0620. So, here is the question number 2. Here, the list of 5 metals is shown: copper, iron, magnesium, potassium, and silver. All metals form positive ions. Yes, we know. Describe how atoms form positive ions. They're asking about how atoms form positive ion. So by loss of electron, by losing their valence electrons or the electron from the outer shell. Some student write by transfer of electron, although it is correct but not appropriate, because loss can be anywhere. But if you are talking about transfer of electron, then transfer of electron means there should be some other species that can receive. Anyway, either use the word losing or transfer. Both are correct, but losing is much appropriate. State which of the 5 metal in this list has the greatest tendency to form positive ion. In other words, they are asking which of these is more reactive. So if we are to write which have greatest tendency to form most positive ion, that I said they are indirectly asking about the most reactive one. So we know that reactivity increases down the group if we are talking about group 1 and group 2, and along the period reactivity decreases. So if we arrange sodium and there is magnesium in periodic table, we can see the periodic table as well, and potassium is here, while copper, iron, and they are not in the group, they are in the Cs, and silver. If you see their arrangement in periodic table, then you will find first iron. Iron is atomic number 26, then 27, 28, and then after gap of the 2 element, there is copper. So copper is less reactive than iron as per this rule, that metallic character decreases from left to right, or the ability to make positive ion decreases. And below copper, there is silver. But silver is less reactive than copper. Anyway, we have to choose one of the most reactive. So down the group reactivity decreases. So magnesium has less activity than sodium, and down the group reactivity increases. So potassium has greatest activity. So the answer is potassium here. Potassium. We have already ruled out all these three because these are the transition metals, while transition metals have very low reactivity as compared to the elements of group 1 and group 2. And among the group 1 and group 2 elements, we can arrange, and in this way we can find out which one is the most reactive. Suggest one of the 5 metals in the list which is not likely to show catalytic properties. So these are the transition element, they show catalytic properties. So which does not show catalytic property, it is either magnesium or potassium. So you can write any one of the name, potassium or magnesium. You should remember some properties of transition metals. The transition metals are hard. They have high density. They or their compounds used as catalyst. They form colored compounds. They form complexes. So we should remember these properties in our mind when we are comparing metals. Instead, which of the five metal in the list is a major component of stainless steel? So definitely steel is an alloy of iron. So the main constituent of steel is iron. Now question number 2, part B. A student adds sample of metal to an aqueous metal salt in a beaker to see if a displacement reaction takes place. To show the complete the table 2.1 to show the color of the solution in the beaker at the start. Here the color in the start is given, and here we are to write, and at the end of the experiment. So in first experiment, think about it. This is a beaker. I'm talking about the experiment number 1. So the solution containing iron 2 sulfate. Iron 2 sulfate means FeSO4. And they said that this is green in color. And what they added there, they added magnesium metal over here. Suppose this is the magnesium strip. So if we see in reactivity series, magnesium is above iron. So if magnesium is above iron, then definitely magnesium can reduce iron. So we can see that magnesium is above iron in reactivity series. And there are some more elements in between them. So magnesium is has more reducing power as compared to iron. So in a solution, magnesium can reduce iron ions. So here iron 2 ions are there, so it can reduce them. So if magnesium will reduce, then the equation would be like this. This is solid, reacts with FeSO4. So FeSO4 is in aqueous form. Then what would happen? A displacement reaction occurs, metal displacement. The more reactive metal can displace the less reactive one, and it forms magnesium sulfate. And it is also water soluble. While iron gets separated, and iron has no charge, and it would be gray solid on there. While the color changes from green to colorless because magnesium sulfate is colorless, and this green color was due to the presence of Fe2 plus ion. And as Fe2 plus ions are converted into Fe, which has gray color, so and it is solid, so it will be settled down, and solution becomes colorless because there would be no Fe2 plus ion there. And now see silver and copper. If you see silver and copper, then we find that copper is above silver. So if copper is above silver, then copper can reduce the silver ions, but silver cannot reduce copper ions. Means if silver is there, Ag solid and CuSO4, it is aqueous, then you will observe nothing, no reaction, because silver is below copper. So it does not reduce Cu2 plus ion. And remember that wherever Cu2 plus ion is there, the color would be blue. Blue in aqueous solution. Their aqueous solution must be blue. Although some of the compounds of copper are green in color, for example, CuCl2, it is green in color, but when you dissolve CuCl2 in water, it gives blue solution because copper 2 plus ion forms complex with water molecule that is blue in color, that appears as blue in color. And there would be no change in color. So color in the end would remain blue. So we shouldn't write no change. We should write the same color. Now, the next part. Group 2 metals form gas when placed in cold water. An alkaline solution is formed. Yes, we know this very, very famous equation. Sodium reacts with water and it produces sodium hydroxide, that is an alkali. Its aqueous solution is there, and hydrogen gas is liberated. Equation is not balanced. So first balance hydrogen atoms, 2 and 1, 3. So first convert it into even number. So there are 4 hydrogen atoms. So write 2 here to make it 4. Now hydrogen is balanced, and fortunately oxygen is also balanced, but we use 2 here to balance the sodium. So most of the group 2 metals form gas when placed in cold water. So which gas is there? This is hydrogen gas. And the same question is here. Name the gas formed when strontium is added to cold water. So it is hydrogen. And better to write the name as the name is required. Okay. Name the alkaline solution formed when strontium is added. As you can see, when sodium is there, sodium hydroxide is formed. When magnesium is there, magnesium hydroxide is formed. So when strontium is there, then there would be strontium hydroxide. And next, one group 2 metal reacts very slowly. If a group 2 metal is reacting very slowly, then you immediately think about the elements at the top. So at the top, the elements are beryllium, magnesium, and calcium. So when placed in cold water, so remember that calcium not reacts slowly. Calcium also react vigorously. So it might be beryllium or magnesium. Beryllium is having amphoteric properties. So beryllium is not discussed here in our O-level syllabus. So when heated, the metal react with steam to form white solid. So in cold water, it does not react. So which metal could be there? This metal definitely, if not beryllium, not calcium, so it would be in between them, that is magnesium. And definitely the white sodium hydroxide. So this is all about question number 2, part C. Part D of the question number 2. Under certain condition, iron will react with steam to form an oxide of iron with the formula Fe3O4. Actually, this is a mixture of two oxide, that is FeO, iron 2 oxide, and Fe2O3, that is iron 3 oxide. So by combining them, we write it Fe3O4. So Fe3O4 react with dilute hydrochloric acid, that is HCl, to form a mixture of iron 2 and iron 3 salt and water. Deduce the symbol equation for the reaction between Fe3O4 with HCl. So see the strategy first. We are writing Fe3O4 and its reaction is with HCl. So we should write HCl here. If you see, this is a metal oxide or the mixture of two metal oxide. So definitely, you have learned in chapter acid base in reaction of acids. An acid reacts with metal oxide to produces its respective salt and water. So water must be formed. And remember that although we will balance the equation afterward, but first we will see how much water would be formed, that all the oxygen in the oxide will form water. So there should be 4H2O. And they have already mentioned that salt contain iron 2 and iron 3 salts. And when a salt is formed, then negative part from an acid, although it is partial negative part from an acid and positive part from metal oxide. So we have two metal oxides, FeO and Fe2O3. In one of them, iron is Fe2 plus, and now it is forming a compound with chloride. Chloride means crisscross method. You can write the formula of FeCl, iron 2 chloride. And another one is iron 3 oxide. So iron 3 oxide, so it would be converted into iron 3 chloride. So we use the same strategy to write down the formula of iron 3 L3. But remember one thing here. Now see the balancing of equation. Although we have balanced oxygen atoms first, but if you see, we can also balance hydrogen as well. So 4 twos are 8. So 8 hydrogen should be there. But how many chlorine are there? 8 chlorine are also there. But here we have only 5 chlorine. So what can we do? If we put 2 here, suppose 2 here, so it would be 2 iron plus 1 iron. 3 iron, iron would be balanced, but chlorine are still unbalanced because 2 twos are 4, 4 plus 3, 8. So not suitable to write 2 here. If we write 2 here, then see 2 plus 1 iron is number of iron atoms are 3. Okay. 3 twos are 6, 6 plus 2, 8, 8 chlorine. Yes, 8 chlorine are there, balanced. 3 iron are there and 3 iron are there. So now it is the complete and the balanced equation. So whenever an oxide reacts with an acid, the salt is formed by combining the metal with the negative part of the acid, and the oxygen, the oxide part, will produce water.